Is there life on a planet 40 light years away? JWST just found a chemical fingerprint that shouldn't be there. For decades, we've been looking for the perfect Earth-like twin. But what if the real sign of life isn't a lush green forest, but a smoggy industrial sky? We are entering a new era of discovery, where we aren't just looking for biology, we are looking for the messy, chemical footprints of a civilization. Today, we dive into the impossible atmospheres that are rewriting everything we thought we knew about the cosmos. Welcome to Sci-Nova. I'm your host, and today we are talking about the James Webb Space Telescope, or JWST, the most powerful eye ever turned toward the heavens. For a long time, our search for extraterrestrial life was pretty simple. Find a rocky planet, find water, and look for oxygen. But space is rarely that simple. As JWST begins to peel back the layers of distant worlds, it's finding things that shouldn't exist, spheres where they were thought to be stripped away, and chemicals that suggest something much more complex than just simple bacteria. It's getting weird out there. Let's start with a heavyweight. K2-18b. Located approximately 40 light-years from Earth, this planet has become the poster child for modern exoplanet research. It's not just a rock. It's a massive world that has captured our imagination. When JWST turned its infrared gaze toward this distant sphere, it didn't just see a blurry dot. It saw a complex chemical soup. The data revealed something staggering: the presence of methane and carbon dioxide in its atmosphere. This wasn't just a guess. It was a clear, measurable chemical signature that changed the conversation overnight. Now, why does methane and carbon dioxide matter so much? On Earth, these gases are often tied to biological processes or geological activity. When we see them together in an atmosphere, it suggests a world that is chemically active, not just a dead, frozen rock. K2-18b is being studied as a potential Hycean world, a planet with a hydrogen-rich atmosphere and a massive liquid ocean. Finding these gases is like finding the smoke from a distant campfire. It tells us that something is happening on the surface, whether it's volcanoes or, potentially, something much more interesting. But then, JWST found something even more controversial. There were tentative signs of dimethyl sulfide, or DMS, in the atmosphere of K2-18b. On Earth, DMS is almost exclusively produced by life, specifically by phytoplankton in our oceans. If this signal is confirmed, it would be the smoking gun for biological activity on another world. However, science is a cautious game. There is significant debate and doubt surrounding this detection, and we need more data to be sure. But the mere fact that we are even looking for a molecule like DMS shows how much the goalposts have moved. This brings us to the core shift in our search: the move from looking for life to looking for technosignatures. A technosignature is essentially cosmic pollution. Think about it. If a civilization becomes industrial, they don't just produce oxygen. They produce chlorofluorocarbons, nitrogen dioxide, and other synthetic chemicals that don't occur naturally. Instead of hunting for a single breath of oxygen, we are now hunting for the smog of an advanced society. We aren't just looking for a biological heartbeat. We are looking for the chemical exhaust of a planetary civilization. But it's not just about finding life. It's about finding atmospheres where they shouldn't be. Let's look at Toy Theory 61b. In May 2024, JWST conducted observations of this planet, and the results were, frankly, mind-bending. Toy Theory 61b is a hot lava planet, orbiting incredibly close to its host star. Traditionally, astronomers thought these rocky planets near hot stars would have their atmospheres blasted away by intense stellar radiation. They were supposed to be naked, scorched rocks. But JWST has found tentative evidence that this planet might actually be holding onto an atmosphere. If Toy 561b really has an atmosphere, It breaks our current models of planetary evolution. It means planets can be much more resilient than we thought. It means that even in the most extreme, hellish environments, the ingredients for complexity might find a way to persist. This discovery forces us to rethink the habitable zone. We used to think life could only exist in a narrow band of distance from a star. Now we're realizing that the rules of survival are much more flexible, and the universe might be much more crowded with pockets of activity than we ever dared to dream. And then there are the giants. While we focus on rocky planets, JWST is also peering into the clouds of gas giants. Recent observations suggest that a massive Jupiter-analog exoplanet may be surrounded by beautiful, complex cirrus clouds made of water ice. Imagine a planet so large it dwarfs our own, wrapped in a delicate frozen veil of white clouds. These clouds aren't just pretty. They are vital for understanding how heat is distributed and how chemicals move through a giant planetary system. It's a level of detail that was impossible just 5 years ago. When we combine all these pieces, the methane on K2-18b, the impossible atmosphere of TOI 561b, and the ice clouds of gas giants, a new picture of the universe emerges. It's not a collection of dead rocks and empty voids. It's a dynamic, chemically active, and incredibly complex landscape. The more we look, the more we realize that the impossible is actually quite common. We are moving away from a binary view of dead or alive and toward a spectrum of chemical complexity. So, where does this leave us in the search for extraterrestrial intelligence? We are no longer just looking for a signal like a radio wave. We are looking at the very air of distant worlds. We are looking for the fingerprints of industry, the traces of artificiality, and the chemical signatures that defy natural explanation. The next decade of astronomy won't just be about finding new planets. It will be about decoding the stories written in their skies. Every spectrum we analyze is a page in a cosmic history book that we are only just beginning to read. The search is getting harder, but it's also getting more rewarding. We've moved from asking, "Is there anyone out there?" to asking, "What are they doing?" It's a subtle shift, but it's the difference between looking for a person in a dark room and looking for the light coming from under their door. JWST has given us the flashlight, and the shadows it's revealing are far more interesting than the darkness we expected. We are on the verge of a paradigm shift in how we define life and civilization. Thanks for joining us on this journey through the impossible skies. If you're as obsessed with the mysteries of the cosmos as we are, make sure to hit that subscribe button and turn on notifications. We have much more coming your way as JWST continues to send back data that challenges our very existence. What do you think? Are we looking for the right things? Let us know in the comments below. I'm your host from Sci Nova, and we'll see you in the next discovery.